Gatekeeper Ltd YG-5602 automatic gate opener. So here's the board, and this is the master terminal that goes out to one of the linear actuators. This is the slave terminal that goes to the other one, and then these are accessory and other terminals. We'll probably end up going through a lot of those eventually. Up here, this one is the DC voltage in. It's 12 volts DC, and then this one is the AC voltage in. So this comes from the transformer. So there's the transformer that is in the control box, and so that normally goes over there and feeds AC voltage into the control board, and the actual AC voltage comes in from your facility right in here, and so the black and the brown and the blue are your black and white wires, and they can be inverted. And over here, this is your ground, so it's your green or copper wire that goes there. Okay, so when we're testing these on the bench, we can only test some functions. We can't test all the functions on the bench. But I have a little bit of equipment that makes it easier, but you can get by without any special equipment really, except a multimeter. You do need a multimeter. So this is kind of a fancy Radio Shack version. It does a lot of stuff, had it for years. And I have a little power supply, pretty cheap little power supply from eBay. So I have it set for 13 volts, just over the nominal 12 volts, and I have it rigged for no more than 5 amps, but you can just use the battery that came with it, charged up, or virtually any 12 volt battery. So what I've got is the leads connected to my transformer, and I'm just going to connect them right here to the voltage side, and then I'm going to turn on transformer. And so the very first thing you check for is we should get a red LED. If you have voltage on it, you can check it with the voltmeter and you're not getting a red LED, then you probably want to go look at these fuses. Okay, there's 2 fuses. One is for the just for the board itself, and one is to fuse the outputs going to the linear actuators. Okay, so let's go through and test the fuses on this one. So right here we've got our multimeter, and it is set to chime on continuity. Every multimeter is different. You'll have to check yours, but this is what this one does. It tells me whether or not we have continuity between red and black when I put it on the fuse. So just put it across the fuse. That's good. That's good. So both our fuses are good. And if you needed fuses, those are sold by Baldwin Pines. www.baldwinpines.com. You can buy new fuses for it there if you need to. Okay, so once we've got the light, we know the board is at least alive at a basic level. Next thing you need to do is program your remote control. So to program the remote control, take it in your hand like this, and you're looking at the board, and the board is alive. And we're going to just press the little learn button right down here. It lights up this little red light. You push the 1, it goes off, push it again, and it comes on and start clicking. That means this remote is now programmed to this board. You need to do it for each remote that you program to each board. So if you have 5 remotes, you have to do this 5 times with each remote. Okay, so we've checked that we've got power. We've attempted to program the remote. If the remote won't program or we don't have power, we're checking these 2 fuses to make sure that they're good. We're checking that we do indeed have 12, 13 volts going to the board. And the next thing that can go wrong, this little loop right here is on the photocell terminals. It has to go from where it says safe sensor to ground. That has to be there, or you have to have a photocell properly hooked up. You can put the wire back as a test, But those two terminals have to be connected, otherwise it's like a safety thing. The board won't really do anything. So you can check that. Check that it goes through the remote programming sequence. And then when you click the button, you should hear clicking. So just because you hear clicking, that doesn't mean the GetUp is working, but it does mean the relays are moving. So I'm going to move my multimeter to the 20 volts section. So we're measuring 20 volts DC. And then when it first starts, it's in what's called the learning sequence, learning its limits. And you're going to put your terminals right there on the slave terminal, and you have to kind of push down on them a little bit. And you should get 12 volts. Sometimes you have to really push down on them to get them in there, so sometimes a better way is actually just to push them through the sides. But you can see I'm getting 12 volts there until it stopped. Then the clicking moves over to the master terminal as it's learning its limits on the master leaf. And you can see, let's get it in here. Having trouble with the camera and but there we go. We've got 12 volts on the master side too. So make sure you take these measurements carefully. You do have to really make sure you're making contact with the probes inside. So that just about concludes everything that we normally see wrong with one of these boards. Of course, it could be an actual malfunction in the board, in which case if testing with these methodologies doesn't reveal that it's a bad fuse or that the board is actually good, then you'd have to send it to us, and you can go to Gatekeeper Ltd.com/support and pick up a work order form to send the board in for us to look at it or buy a new board from there. There's one other thing, and that is the power switch. If you have the board out of the box like I do, it's not an issue, because once this is unplugged, it's automatically on. But when you're looking at one that's still in the box, this goes to a power switch, and we have had people in the past accidentally leave it turned off like that, and when it's off, the board's inert, so it won't do anything. So you need to make sure it's either on or just remove the power switch out like that. Okay, so I hope this helps with diagnosing this kind of board.